I'm Anil Kumar. We are exploring the idea that if f is any antiderivative of the positive function f, the area under y equals to f of x from a to b is ab equals to f of b minus f of a, right? So that is how you can find area under the curve. So the question in particular, which we will discuss in this video, is find area of the region below f of x equals to 9 minus x squared and above x-axis. So let me sketch this function here and then we'll discuss. So it's a parabola which opens downwards, and if x is 0, it is 9, correct? So I could sketch this parabola kind of like this, right? So we could do a parabola like this. Okay. So what we have here is that we need to find area of the region of this function and above x-axis. That means above x-axis means this, right? And all this. This is what we need to find, right? So let me just shade this. So this is what we are interested in finding. Okay, so that's the area which we want to find. Okay. How do we do so? So we need to find what those x-intercepts are so that we know the boundary within which this area is to be calculated, right? So that is important. So let's equate the function to 0. So we are given f of x equals to 9 minus x squared. So let's find these x-intercepts. So at x-intercepts, f of x, this function, this is x-axis, f of x is equals to 0. So we'll equate this to 0 and find what is the value of x, right? 9 minus x squared, or x squared equals to 9, x equals to plus minus square root of 9, and that gives us x equals to plus minus 3. So this point is minus 3 and that is plus 3 for us. Is that okay? Now that is first part. So we found that the x-intercepts are at plus minus 3. Now the question really is that we need to find area under the curve between minus and plus 3, right? So FB and FA are known to us, right? So we are going to use this particular method of solving, that is to find antiderivative for this function. So let's find antiderivative of 9 minus x squared. 9 antiderivative is 9x minus x squared will be x cubed over 3, right? We'll choose c as equals to 0, so I'm not writing plus c. The idea is whenever you're given two limits, that c cancels off when you do fb minus fa. Perfect. Now to use this formula, we need to find, since the interval for us is between minus and plus 3, fb is 3 for us, so we'll find what is f of 3. We'll substitute here 9 times 3 minus 3 cubed over 3, right? So you can use the calculator to figure this out, or otherwise you can do, right? Well, you know, f of 3 in this case is 0, and okay, so this is the derivative, right? So let's use the calculator. 27 minus 9. Anyway, let's use calculator. 9 times 3, take away 3 cube is 3 square divided by this, so it gives you 18, right? So that is 18 for us. And let's also calculate what is f of minus 3, right? F of minus 3, this is antiderivative. So we'll put 3 times minus 3 minus 3 cube over 3, right? So that basically becomes, this is minus 27 and this is negative 27, and negative becomes positive, right? So it is positive 9, and that will also give you minus 18 this time, right? So instead of positive, you get negative minus 18, correct? So that is f of minus 3. So the area under the curve, which is, we are saying area from minus 3 to 3, that is the b, is equal to f of 3 minus f of minus 3, correct? And that is f of 3 is 18 minus minus 18, which is 36 unit square. So that is how you can find the area under the curve using this concept. That is, if f is any antiderivative of positive function f, this is positive in this interval, the area under y equals to f of x from a to b is ab equals to f of b minus f of a. So that is how you can do it. I hope you find it interesting. Thank you and all the best.